So in this video, we're going to do stoichiometry involving solutions. So determine the mass of aluminum required to react with 25 milliliters of 6M, and this stands for concentration. Remember that this is another way of writing moles per liter of hydrochloric acid. So the first thing we have to do is figure out what's reacting together, and again, keywords react. So aluminum is going to react with hydrochloric acid. So aluminum goes with Cl. Aluminum is 3 positive and chlorine is negative, so it should look like this. And what we have left over would be hydrogen gas. This is actually one of the reactions that we do in lab when we're determining molar volume of a gas. Next, we just need to balance it. So I'm thinking if I put a 3 in front of here, that makes an odd number of hydrogens. So what if I do 6? Then I could balance out the hydrogens. Now I have 6 chlorine, so I need to put a 2 in front of here and a 2 in front of here. Remember that when you're balancing, you want to make sure that you can't divide all of the coefficients by the same number. So let's say I can't divide them all by 2, or they can't all be the same number, so they all shouldn't be 2, 2, 2, 2, for instance. Okay, now it says determine the mass of aluminum that I need to react with a volume and a concentration of this. So the first thing I have to do is figure out the number of moles of the thing I have numbers for. In this case, it would be the HCl. Now remember that the original formula that involves solutions for concentration is this one, right? And so we want to do V times C to figure it out. Now I'm going to write in 6 moles per liter. I just want to point out that if I write in milliliters, right, like this, notice that milliliters are gonna, sorry about that. Okay, so now if it's in milliliters, notice that I would cancel off liters. I'd get something called millimoles, and we don't want that. So you make sure that you change your milliliters to liters by moving it over 3 decimal places. So now we're going to do on our calculator 6 times 0.025. And I get 0.15 moles. Now I need to figure out the number of moles of aluminum by using the mole ratio. So this was the moles of HCl. I don't want moles of HCl, so I'm going to put the 6 moles of HCl down here. And I do want moles of aluminum, so I'm going to put that up there. So now I'm going to take the number on my calculator, times it by 2, and then divide by divide by 6. I was thinking about that 2 divided by 6 is actually 1/3, so really you could take the number in your calculator and just divide by 3. But if that's confusing, just take the number, multiply it by 2, and divide by 6. So now I get 0.05, and this is moles of aluminum now. And now we need the mass. So to get the mass, we're going to do 0.05 moles of aluminum times the molar mass of aluminum, which is 26.98. So we're going to take that number and times it by 26.98. And we want to have 3 sig figs, so 135 grams is our final answer. Okay, let's try another one. Determine the concentration of nitric acid solution if 43 milliliters is neutralized by lithium oxide or lithium hydroxide. So lithium is positive, hydroxide is OH negative, nitric acid is HNO3. Anytime you have a neutralization reaction, you're always going to produce one of the things is going to be water, and you can actually see it here. So here's the hydroxide from here and the hydrogen from here, making this water over here. The other thing that we're going to get in this case is going to be lithium nitrate. Lithium again is positive, nitrate is negative, so they combine just like that. So now I have 2 hydrogens here, 2 hydrogens here. I have 3, 4 oxygens, and I have 3, 4 oxygens, 1 lithium, 1 lithium. So it's already balanced the way it is. So it wants me to determine the concentration of this thing if I have 43 milliliters. Oh, if 43 milliliters of it, so that's the volume, is neutralized by 25 milliliters of this and this concentration. Okay, so first I have to figure out the number of moles of the thing that I can. In this case I have a concentration and a volume, so again going back to the original formula, therefore C times V is going to give me the number of moles. So I'm going to take this and times it by this. So remember to convert again to liters. Okay, so 4.5 times 0.025 gives me 0.1125 moles. Now I want to figure out the number of moles of HNO3 by using the mole ratio. So I'm going to take the moles of lithium hydroxide and we're going to times it by the mole ratio, which is going to be an easy one because it is 1 to 1. Now I'm just going to end up with moles of HNO3. Now I can actually figure out what the question is asking me, which is the concentration. Remembering to change the volume to liters here. So I get 2.62 moles per liter. Great, one more question.